Welcome back, everybody. In our next section for Switch Campus, we're talking about VLAN Trunking Protocol, or VTP. So in this section, we're going to talk about the VTP version 1 and 2 modes, authentication, and pruning. So first and foremost, what is VTP? It's used to synchronize the VLAN creation between the switches, and it's used to simplify the management. Now, it's not a requirement of Ethernet networks. It doesn't define the broadcast domain. So we saw in our previous example, we were creating VLANs locally. We didn't use VTP, but we were still able to reach the destinations that we were trying to ping because the VLAN information is local. So in VTP, we have three different modes of operation. We have server, client, and transparent, where server is going to be in charge of creating the VLANs, advertising them, and then installing the VLANs from the other advertisements. The VTP client cannot create VLANs, but it can advertise them and it can install VLANs from other advertisements. And last but not least, the VTP transparent switch creates locally significant VLANs. It forwards other VTP advertisements, but it doesn't install VLANs from other advertisements. Now, the traditional problem with VTP has to do with what we call the configuration revision number, which is effectively the sequence number for the database, and whichever switch has the highest number wins. So the domain is synchronized when the revision number matches everywhere. The problem with this is that if the wrong database has a high config revision number, it can overwrite the database of the other switches. So this is true of both a VTP server and a VTP client. Okay, the idea here is that you have a switch and you have it in development, but you're using the same VTP domain name as your production one. You plug the switch in from development into production. If it has a high revision number, it can overwrite the VLAN database and potentially cause an outage. Okay, because of this, VTP version 1 and version 2, they're rarely used in production because it is a pretty big hole that you could just overwrite the entire VLAN database with one incorrect command. Okay, VTP authentication isn't going to fix this problem, unfortunately. It's used just for validating the VTP updates. So when you join with the new password, it's not going to affect the revision number. Whoever still has the highest revision number is going to be the one that is advertising the VLAN database. Okay, VTP pruning is another useful feature of VTP, which is going to reduce the unnecessary replication of broadcasts, unknowns, and multicasts, or what we call BUM traffic, B-U-M. This is supported only in server and client mode, and the idea here is that it's going to automatically edit the trunking allowed list for only the VLANs that you actually have assigned. With VTP pruning, only VLANs 2 to 1001 are eligible to be pruned or able to be pruned. VLANs not in the prune eligible list cannot be pruned, so traffic will always be sent and received from them. So we can edit the prune eligible list, the switch port trunk pruning VLAN, but this is basically the opposite of editing the trunking allowed list. So if the VLAN is in the trunking allowed list, but it's not in the pruning list, it means that it cannot be pruned, meaning that it's going to always be available on that interface. So it's kind of a reverse logic. Now, one of the other issues here with VTP pruning is that VTP is Cisco proprietary. So if devices don't agree on the revision number, or if there's transparent switches in the network, those pruning messages can propagate through them and then cause problems with the trunks. Okay, so let's take a look at an example of this on the command line. And first thing we're going to look at is the show VTP status. It says we're running version 1 and the operating mode is VTP server. Okay, first step for VTP is we're going to configure a VTP domain. We'll say INE. If I could spell it right, INE. And if we now look at the other switches and show VTP status, they learned the domain name. So actually they learned the one that I had the typo in. Let me change this back. VTP domain IE. So this is automatically going to be inherited if we don't have any VTP configuration. Show VTP status. Show VTP status. And finally show VTP status. Okay, the domain name is now IE. So on any of these VTP servers who have config revision number 4, Okay, we can tell that the network is currently converged with VTP revision number 4. Any of them can create the VLANs and then have them advertised to the rest of the network. So we created VLAN 146 and 37. We go to switch 2, we look at the show VLAN brief. We now have VLAN 146 and 37. Okay, if we were to turn VTP pruning on, show VTP status, VTP pruning mode is now enabled, so this is another option that gets advertised dynamically between the switches. And if we show interface trunk, let's look at the show interface gig 01. Pruning. It says VLANs pruned for lack of request by neighbor is none. VLAN traffic that was requested of the neighbor, this means that these VLANs are in usage and they're requesting that we trunk them over there. Okay, like I mentioned, the VTP prune eligible list is going to be the opposite of the trunking list. So if we say switch port trunk, or actually what's the command here? It is switch port trunk pruning VLAN. Switch port trunk pruning VLAN. We want to remove, let's say 146 from the list. And if we show interface gig 01 pruning, it says traffic requested of the neighbor is VLAN 146 because this is no longer in the prune eligible list. Okay, for VTP authentication, we just have a simple VTP password. And if we look at the show VTP status, what we're going to be comparing here is the MD5 digest between the switches. Show VTP status. We would see that between switch 3 and switch 2, we now have a different digest, and they won't be able to exchange updates. So VTP password is Cisco. Show VTP status. And we should now see that the MD5 digest is going to be the same between all 4 of them. Show VTP status. And again, what we're really looking for here is the revision number. So every time we make an update, VLAN 12, show VTP status, we have a new revision number. Okay, we also have a new hash because the revision number is part of the salt. And if we show VLAN brief, we should see now the VLAN database is going to be converged between all 4 of the switches. So it definitely is a useful feature, but there are some of these problems that we would want to avoid, mainly with the revision number, that if someone has a higher revision number, they're inserted into the network and then they overwrite the VLAN database.